What up, dudes? In Algebra 2, I sent out an email the other day, yesterday I think it was, and said, hey, I'm kind of disappointed about how many people are not showing up for class. And now today I have 3 people at the beginning of my class. I think I even sent out the words like, show up for class, don't be late. Right? And the sad part is, and the reason why I started the recording is because I'm realizing that I'm yelling at the choir. Have you ever heard that? You preach to the choir? It basically means that, like, I'm telling the people who actually show up that no one's showing up. So, actually, Caitlin, Travis, Elijah, this is not relevant to you. And by the way, Elijah is hanging out here with me. There he is. And we're going to get this party started. But for those of you, the 3 people that I mentioned, you guys showed up on time and not late. For those of you who are watching this video, that means you didn't even come into class or you're late. Yeah, I'm talking to you. All right. Anyway, why don't we get started with this stuff? I'm going to try doing some screen share. I pushed a program out to your Chromebooks. I wonder if you guys got it. Did you guys notice a new program pop up that says Desmos? Have you seen that thing? Were you wondering what that was? It's a cheater's tool that I'm giving you. It's called a graphing calculator. And basically, this homework assignment is going to ask you to graph a whole bunch of stuff. And you want to know what you can do with a graphing calculator? You can graph a whole bunch of stuff. So therefore, that kind of makes your homework a little easier. Do you guys agree or disagree? All right, so now what I'm going to do is I'm going to try sharing my desktop. Let's see if this works. What I'm going to do is I'm going to turn off my computer, like my video, because I don't want to run too many things. Turn off my video, share my desktop, and then see if if both of us can get onto the graphing calculator thing. Let's see. Okay. Can you guys still hear my voice? I want to make sure, because it seems like this thing is running a little slow. The big blue button. All right. Awesome. Now you can no longer see my face, am I correct? Okay. Because this thing is running slow, I'm going to back off. I'm going to back out and log back in. I might be kicked out, but I'm going to jump back in, okay? Because Firefox just froze. Urgh. Technology. It's fun. Can you guys hear my voice while this thing takes time to think about wanting to work? I just got to make sure. I need to make sure that you guys are responding. Because it doesn't seem like it. Elijah, maybe you should log in. Put headphones in, and that way you can verify to make sure that I'm through. All right. Technology, it can be your friend or enemy.
Did you forget to do WebEx when you had floppy disks?
I don't know how we would do WebEx with floppy disks. All right, I'm going to log out and log back in. Give me a second. That was a short stint of working. Thank you, big blue button. There we go. We got some other people in here. Wow. How's it going, you guys? Can you guys hear my voice now? Good? Awesome. Awesome. Good, good, good. All right, I'm going to try sharing my desktop. Let's see if the computer likes it. It's going to take a second. So while I'm taking a second, here's what I want you to type. I want you to go over to Desmos. Try going to that Start menu. It might be in the 3rd folder to the right. And there should be a, I don't know what the icon looks like. I forgot what it looks like, but it says Desmos. Yeah, it's actually on the bottom, and it looks like a little squiggly lines, like a graph. Actually, you know what? You don't even need to worry about it. Go back into the. No, I'm telling you guys, go back and forth. Go back into the thing. It looks like go back into the big blue button. It looks like my desktop is actually sharing the thing I wanted to share. So I'm going to actually just go to Desmos because Desmos is an app that is built into your computer, but it's also an app that's on the web. So I just type in Desmos graphic calculator. There we go. When I get there, it pops up. It looks like this. Is that similar to what you guys see? Can you guys see my computer screen? I'm going to write a word. Tell me what I wrote on the computer screen just to make sure that you guys know what I'm talking about. Oh, it's tiny. Let's see. All right, here we go. Okay. Oh, you guys see it. You guys, it says Bob. All right, good. So Bob is working. All right. So now we'll do this. All right, so you can see my computer screen. I need to be able to see this thing. But anyway, I'm going to start working with this Desmos thing. I'm going to show you guys how to graph something. It's really easy. You just put y equals x squared. And look, we have a, what is that called? Reminds me of a virus, doesn't it? It's called a parabola. Very good. Awesome. Okay. Yes, it is a parabola. The reason why it reminds me of a virus is because it's like the Ebola virus, but then it's a para-Ebola. Maybe it's a special form of the Ebola virus. I don't know. I don't really know what I'm talking about with that because I know nothing about viruses, but I have a friend over there who's a biology teacher, and he knows what he's talking about. Anyway, I'm going to try changing this equation. So I'm going to write underneath it y equals x squared, and we're going to explore what that looks like. Obviously, those would be the two same graphs, right? The blue one and the green one would be the same graph. But if I put a number in front of here, like a 2 times that, 2 times x squared, what happens? What's going on? What's wrong?
I don't know. I think I'm in trouble.
Okay, anyway. They are having drama out there. This would be Elijah and Brandy, so I'm not going to get in between this drama that they're having. Anyway, it gets skinnier. Exactly, Kalen. It got skinnier. And if I put a bigger number there, instead of a 2, I'll put a 3. Or instead of a 3, I'll put 100. What happens to that graph? Come on, type it back to me. Help me out here. Talk to me. It gets even skinnier. Exactly. There we go. So, putting a number out in front there will make it skinny. Now, if I did a smaller number, like let's say 1/2, what happened? What happened to the green graph as it relates back to our general graph? It got wider. Exactly. There we go. And the way I think about this is it didn't necessarily get fatter. What I like to think about it is tall and short. I was going to say it didn't get fatter because fatter is offensive, but it's not like, I did any better by saying, well, this one's tall and this one's short. Yeah, sure, that's not offensive. Of course, this is coming from a short guy. But anyway, the 1/2 means it got shorter. And what I mean by shorter is here. Let me show you something, okay? Let me do this. I'm gonna. That's all right. All right. I'm gonna go and switch to my webcam and see if that works. Hopefully, I'll be able to switch back and forth between these things without it freaking out on me. Because that's the way it should work. All right. Now I'm gonna open up one of my favorite snacks. All right. Can you guys see my face again? Okay. Katsu. You guys are like, I'm gonna open up one of my favorite snacks. You guys are full on like, what? Katsu? He's gonna eat katsu in front of us again? And I'd be like, no, I'm gonna do even better. Gummy bears. In fact, Elijah you can have one of my gummy bears
Yes.
since you came in. Here we go. You guys ever play with gummy bears? I gave gummy bears to my kids the other day. You guys ever eat gummy bears? Yes? No? Can I come upstairs and get... Wait, Kaylin, are you here? Are you physically on campus?
Yeah, she's part of the chemistry class.
Of course you can come upstairs and get one. Come upstairs and get one. Kaylin, I was talking to you earlier. You keep in mind, Kaylin, I don't see faces. I just see the names. I didn't know who I was talking to. I was just trying to make nice conversation. Kaylin, you can have one. In fact, I'll give you two. Just to be fair, I'll give you another one.
Yeah.
There we go. These are two gummy bears put on the side for you. But I asked you, have you eaten gummy bears? And none of you answered, so I'm going to assume no, and I'm going to say, what kind of Americans are you? Haven't eaten no gummy bears. Now see, I gave one to Elijah, and he ate it wrong.
Oh.
Yeah, totally wrong. How do you eat gummy bears? I'll show you how I eat gummy bears. You guys want to see? You ready? Please don't eat me! No! Ah! Wow, these are tough gummy bears. Ah! Nom, 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 nom. Nom, 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 nom. Don't tell me you guys don't do that. Or, you're squishing me. Ah! Nom, 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 nom. Come on. Even adults do it. Right? Along with everyone at least eating gummy bears. You've done that, right? Right? Yeah. Yeah. I do too. Now notice, when I pull the gummy bear this way, what happens to it? Let's compare. In fact, here, Elijah, you can have another gummy bear, but hold this one. Now hold it on the camera so that they can see it. And I'll hold this one, and we'll compare, okay? Our gummy bears, here, hold it about the same. There we go. Our gummy bears are the same height and the same weight. They're the same width and all that kind of stuff. Now, when I take this gummy bear and I stretch him, you don't touch yours. We're just using yours for comparison. And I stretch him. What happened to my gummy bear? Or got? Well, come on, answer. Sam, Travis, Kaylin, here you can have gummy bears.
Yay!
Here.
Thank you.
In fact, you can log out of the class and just sit by Elijah if that's all right. Can you guys share a chair, or
I can actually fix that.
you know what you can do is if you want, you can carry that chair over here. You can sit right next to me over here. There. Whoop up. Don't get the guitar. All right. Have a sat, Elijah. I'll make myself as skinny as possible. Okay, Brian, check. There we go, Joanna. You got it, Sam. It gets skinnier and taller, and that's kind of what I think. When I put a 2 in front of that parabola, in my head I'm thinking when I'm doing it is I'm stretching it vertically. What that translates to is it makes it skinnier, right? And I think of a gummy bear when I do this. Because when you take a gummy bear, you say, please don't eat me! Ah! And you stretch it like this, it gets skinnier. I mean, that's obvious, right? You guys can imagine this. No, you don't even need to imagine it. You can just watch Mr. Dalton eat gummy bears. Right? So it got taller, but it got skinnier as well. That's what's happening to the parabola. You're stretching it vertically, making it skinnier. Now, if you're a real punk, you also do this to the gummy bears. And then I showed my kids this past weekend. I gave them gummy bears, and I said, you know what, you guys, you should play with them, right? Because I saw them wanting to do it, and then they were like, I don't know if I should play with my food, so my dad's going to get angry at me. And I started being like, no, don't break my arm off. And then they were like, Oh, full on. So man, they were getting creative with how cruel they were being to these gummy bears. But anyway, if I take this gummy bear and I squeeze it, what kind of happened to this fatso over here? He got fat, right? When you kind of like squeeze him, his that's kind of what happened to me. That's how I explain it. I used to be tall and skinny, and now I'm kind of short and just extended out that way. So what happened is when you compress it, it got fatter. So if I put a 1/2 out in front, it's not a 2, but let's say a 1/3, that compresses the parabola, but I kind of think of it as making it wider. Does that make sense to you guys? Yes, no, I agree, I don't agree. All right, awesome, awesome. All right, so when I graph this, and by the way, you can now use your Chromebooks as a graphing calculator using the Desmos program. Then what we can do is you can see that if you graph 2x squared, it's going to be skinnier than this dotted graph. If you graph 1/2 x squared, it's going to be fatter than this dotted graph, right? And if I graph negative 2x squared, what is that going to do? Tell me. What is the combined effects of what that does? I'm going to ask you, and then I'm going to tell you to go and try it on Desmos and tell me what actually ends up happening. You can tell me, by the way. Yeah, I mean, you can just say the words out loud if you want, since you can't type. I mean, you can type, you just can't type because you're not logged in. You want another gummy bear? Yeah. Sharon, I think you would get a kick out of the lesson that I'm doing with gummy bears. All right. So, wait. You got to tell me, what would happen if I put a negative 2 in front of my x squared term? It will what? You can say it.
It'll be upside down. It'll go downwards.
It will be upside down. What we mean by go downwards is mean the way it opens up. Okay? Positive parabolas open upwards, and by opening, I kind of think of it kind of like it's a bowl that's opening upwards. And negative parabolas is like a bowl that's opening downwards. You take the bowl and turn it upside down.
Good morning, Manny. How are you?
Does that make sense?
Where is that?
Cool. But what else is going to happen? I'm putting a negative 2 in front of there. Not just a negative. And you guys got to respond. I got to know whether or not the class is running. Because I feel like, what happened to everybody? Oh wait, okay, there we go. What is the 2 part of the negative 2 going to do? We established what the negative would do.
Josh, when are you available to meet with Diana?
Today?
Yeah, they're not available till after lunch.
If you look at my schedule, I go from 9 to 12 and then 1:30. With like 2 5-minute breaks. Today is
Well,
9.
we're quite concerned about the budget for science and that we don't have anything for you and that you all didn't sit down together as a group.
I can do it at
Put
12.
together
I can do it at exactly at 12.
You have to ask Maria if she's free.
Okay. Someone's calling me. Can I? Hello? Hello? Okay. All right. All right, I'll call them back. All right. So, the 2, okay, so the negative obviously flips it upside down. We got that, right? The 2, well, what did the 2 in the first one do? It made it skinny. So the 2 in the negative 2, once we put it in the negative 2, we'll make it skinny as well. So if I have a negative 2 in front of my x squared term, I look at the Desmos, and I know you guys can't see it on thing because I'm not sharing my desktop, but I want you guys to type it in Desmos, type in negative 2 x squared, and you'll see a parabola that is upside down and slightly skinnier than the regular parabola that you see normally. Is that, you guys agree? Do you guys say yes, I see that, or no, I don't see that, or no, no, I don't see that because I'm too lazy to type it in exactly what you asked me to do? All right. Good. Good. So, I play with it when it's in my mouth too. Going like, come on, you guys don't need gummy bears like that? What kind of American are you?
In private, maybe, but not.
Oh man. Alright, Anyway, what's really cool about that is you can kind of alright. Then what we're gonna do is we're gonna look at that +1 part over there. Okay? Because look, what we're analyzing is this. Alright? What we're analyzing is y equals ax squared plus bx plus c. Okay? Can you guys see that? Y equals ax squared plus bx plus c. Now what we're analyzing is we're saying, all right, this is a little bit too complicated to analyze straight off. So I'm going to let b and c be 0 for now, and I'm just looking at ax squared. Right? Now a, we've established that a does something to it. If a is a positive number, it makes it skinny. If a is a fraction, it makes it fat. And I don't like saying that instead of a is a positive number, it makes it tall. If a is a fraction, it makes it short. If a is a negative, it flips it upside down. We've established that, right? Okay, so we've got a. Check. We understand that. We can look at a graph and we can say, hey, that's what it does to it. Cool? Now what we're going to do is we're going to add in that c. So we have y equals ax squared plus c. That's what we are now analyzing. So let's see what the c does. Go back into Desmos, okay? And I'll tell you what, why don't I do another screen share and see if that works again. Can you see the computer screen?
That's your desktop.
Oh, wait. Can you see my desktop? No, you cannot. Huh? I don't think it works twice. Oh, you got it? Awesome. Alright, so you guys can see the desktop. So what I want to do is I'm going to type in y equals x squared. That's my regular Desmos thing, right? And then I'm going to do a y equals x squared x caret 2. Press the right arrow. And then I'm going to put a +1. You tell me, before I do it, what do you think is going to happen? Let me go back to the chat so I can see. What do you think is going to happen? What is your guess? And if you don't know, then say, I don't know. I just want to hear a response from you. I want to know that you're alive. That's what I want to know. The graph is going to start at 1. That's what Sam Cash says. Big money. All right. Kaylin?
Start at 0, 1.
We'll start at 0, 1. What do you mean start at 0, 1? That's what I'm wondering. The vertex. Okay. All right. I agree. All right. I see what you're saying. Let's try it. Let's plug in a 1 there. What happened? Did exactly what you think happened happen? Yeah. Yeah. Are we cool with that? Like, I like that. I'm down with that. Good. Awesome. So you guys understand why? What I see it do is it basically pushed the whole graph up by 1 unit. Okay, go back to the big blue button. I want to see what you guys see. Oh, it's interesting. There's so much things happening on that computer. All right. It pushed the entire. I think I'm sharing the desktop thing within the thing. It's crazy. All right. I think of it as you take the regular parabola and then you push the whole thing up by 1. Everyone agree? All right. Now, without even plotting numbers, let's take a look at that 2x squared minus 1. All right? Let's talk about what that's going to do. What is the 2 going to do? And I need to go quicker, you guys. Come on. Get it moving.
Make it thinner and then it's going to aim down.
The 2 is going to go thinner, right? Now, Elijah's saying that it's going to aim downwards. What do you mean by that? You think it's going to flip over like that?
Yeah, the opening is going to be towards.
All right, so it's going to be thinner and flipped upside down. What else is it going to do? Is that it?
The negative one is going to put a negative one part of the y-axis.
So Elijah thinks the graph is going to look like this. It's a little skinnier, it's flipped upside down, and it's moved down one. Is that what you're saying? All right. You are absolutely wrong.
Oh.
He's close though. Come on, help him out, you guys.
Is it?
Look at it. We're looking at y equals 2x squared minus 1. What is that going to do? I mean, you can try it, but I want to know, what is 2x squared minus 1? It won't get there. Sam, good job. You're still wrong. Sorry, Sam.
Get thinner and start at 0, negative 1.
What is that?
You'll get thinner and start at 0, negative 1.
She says it gets there and start at 0 or at negative 1. Elijah agrees with it. He added one thing. He says it's going to flip over, and you're saying what?
It's going to stay positive.
It's going to stay positive. Why?
Because the one in front of the x is positive.
Ah, there we go.